Hi, and welcome to this a lecture in the series of lectures on C# programming. This lecture will look at list boxes, and I am your presenter, Dr. Peter O'Neill. Okay, purpose. Most programs process sequences, lists of data. For example, a list of names in a database, a list of files in a folder, a list or collection of bytes in an MP3 file, the text of a website, and so on. Operations. Arrays, lists, each are collections and are quite similar to each other. Each tend to support the following operations. Create a new list. Insert a new item into a list, e.g. insert item at the end of list or insert new item at position 37. Amend an existing item, e.g. amend item number 32 to Peter. Delete an item, for example, delete item 24. Recall item, e.g. stored item number 27 into X. Design time. First, we place a list box onto our form by selecting it from the toolbox. Here we are, this is our toolbox, and as you can see the mouse is placed over the list box. Click on it and then drag it onto our form. Once placed on the form, we can create the content of the list by placing our mouse cursor over the list box on the right mouse button. And a list box pops up, funny enough, which is a menu. And on the menu is Edit Items. We click on this one and add items to the list. So here I've added bread, milk and coffee. Items appear in the list frame. Here you are, so when we close that and say OK, there they appear on the list in the actual frame itself. What is to be noted that the list and the frame, or the box and the frame, the box and the list, are really two items that are brought together to give us a list box. So in fact you can use lists without a box too. This is just about all you can do at design time. However, runtime. At runtime, add items to the list. I've created a nice face. We've got our list that's on the right hand side, bread, milk, coffee. We've got our add button, which is two chevrons pointing to the right. And then we've got a text box. And we've got a label saying enter item name. And what we do is we enter the name into the text box. Well, by the way, you can see this example on the blackboard under list boxes. So we type the item title into the edit box or text edit box and click on the add button. Of course, nothing happens. Why? Because we haven't written any code yet. So let's have a look at the code behind the button. So double click on the add item button, enter the following into the code area. So here's our event that's been created by our double click. And there's open squiggly brackets. That's where our event begins, remember. And then we've got the name of our list along with its path. And we've got shopping, items, add. And then we've got the name of the text box, which is item to add, text box, and dot text. Remember, item to add text box is the box that contains the text, not the text itself. And it's the text itself that we want to actually put into the item. So we have to give it the full title of what it is and its text itself. And then we've got our squiggly brackets. So let's quickly go back through that again. I normally read it backwards, but in this case I will read it forward. So, shopping, items, add. From the text box, the text. Okay? So it's as simple as that. Okay, runtime. Runtime, we can also add functions to tell us what number the item was within the list box. E.g., first we need to add a button. So we've added a button to our bottom of our thing, say number of the item. Really, it would have been better saying item's number, I suppose, which is here. And you can see this in examples, list boxes number 1 on Blackboard. Again, we need to add the code behind the button. So here we are, BTM button click, open squiggly brackets. You will note that both of my buttons have got the same name. That is not possible. I've just copied it over because it was quicker to do so. So don't do that yourself. If you double click it, it will automatically give it a name associated with what you've called that button. So that's one of the reasons why you should label your buttons before you double click and create an event, because that way you'll get the proper name. Okay, so it's open squiggly brackets, then it's messagebox.show, and it says shopping items count to string. And close squiggly brackets because that's the end of the event. So let's have a quick look at it again. So message box we're all familiar with, and show, so we'll not even look at show. And we've got our shopping list, the items that's in it, and we want to count them. And count will give us back the number that's contained within. However, it is a number. A message box, remember, takes strings, therefore we must convert it into a string before we send it back. Runtime, on clicking on the number of items button, we get the value 3 back. Clever little programmer. The bell sounds and the focus is moved to the message box with the result being shown. At runtime, we can clear a list box by adding to a button on its event the following code. Shopping items clear. Open brackets, close brackets, semicolon. But what if we wish to select an item in a list box? Of course, we can do it with a mouse, because we can click on the left mouse button on the desired item, so we can actually select it quite easy using a mouse. But how do we do it programmatically? However, remember what I said about clever programmer? So what was all that about then? Well, you see, indices starts at 0. So if we choose the first item in our list, it's not number 1 item, it's actually 0 item. But remember, when we clicked on the third item, it gave us 3. So that's what I meant by clever programmer. He looked at the indices number and then added 1 to it so that the user wouldn't be confused. So here we go, look. Index and attribute. So he clicked on coffee and got 3. Well, actually, the index of it is 2. So the clever programmer remembered to put an extra 1 on and incremented it to make it the 3 value that it should have been. So selecting coffee using the mouse. Here we go. If we get the indices, which we have here, yeah, and it says in the box, it says the item you've selected of index 2. So it's telling you that it's not number 3, it's actually index 2. Coffee, number 2. And you can see that example in ListBoxes, number 2, again, available on Blackboard. Coffee, of course, is the third in the list, but is displaying 2. Can we do this with another way? Tell the application which index we want and have it display the relative item. Okay, so we have to change our interface. So that's our number, that's our selection, and that should be the result. And that can be seen in ListBoxes number 3 on the Blackboard. Let's have a quick look at what's behind the button on the code. So we've got button, void, again I'm using the default one to save me having to keep typing them in. But this will be done automatically if you make sure you label it before you double click on it. Then we've got our open parentheses, and we've decided to declare locally int the index, so it's an integer type, and then we've said the index will become converted to int 16. I now recommend, by the way, you using 32 rather than 16. Items, open brackets, by the way, there shouldn't be 2 open brackets, it should be 1. Open brackets, item required n for number, text box, dot text. So the actual box that's got the number in is called item required n, text box, and the actual text is the value, and we're converting that on the fly so that it will become an integer so that we can use it later. That gets us the number of the item that we've entered into the interface, and then the next bit actually has to get that number or that item from the list. So item is string, so item is, and I put it's a string, text box dot text. So we're putting it into the box called item is string text box, and we're putting it into the text attribute of that box, and it will become the shopping dot items open squared brackets the index close square brackets, and then we need to make sure we convert that to a string to make sure it's compatible with the text, which is a string in the text box. Okay, then we've got our close brackets. So let's quickly go through that again. Got an index which is declared as an int. We then get a value from the actual interface by looking at the number placed inside the item required n text box dot text, and we convert that on the fly and put it into the index. and then we convert to the string the index at the item of the item at that in that shopping list, and it becomes the text of the text box. What if we entered a number outside of the boundary? So here we are, 8. Well, clearly we've not got that many in. So when we select our button, we will get the following. We're going to get an error. The item you requested is outside of the boundary. Therefore, no item can be displayed. Now, that is not done by the machine. So we need to go and have a look at our code and change it so that we can explain that we want this to be actually displayed when things are outside of the boundary. So let's have a look at the code again behind the button. So here's our original code with a few extra bits in it. So we've still got the index. We've still got it to convert it into. And then we've got to convert it into an index number, and put it into the index. And then we need to quantify whether or not the index is greater than 0. Because if it's 0, it is the first one. So if it were -1, that means nothing's selected at all. Or -10, nothing's selected at all. Right? And we want to check that it is actually the ampersand is basically saying and the index is greater than shopping items count. And only if it is do we then use the index in our output string. Okay, which is that, as before. However, if it isn't within them boundaries, we now output the item you have requested is outside the boundary of the list. Therefore, no item can be displayed. Okay? We can also remove and add items at a particular point within our list. And the code for these are remove item. So here we go. Shopping item remove at, and that is the index, I believe. Okay? Insert item. So it's shopping items insert 5t. I believe that is also at an index. Remember, the index starts at 0. This catches lots of people out, especially when they're starting off, because we always assume to start to count at 1. But of course, computers do not. I'm not going to do the months of the year, which are in the notes, but I'll let you have a go at those during your tutorial sessions. However, I do wish to look a little bit at the arithmetic. Up to now, lists have contained characters or strings, and they will always contain characters or strings. And there's only one instance where we've converted the number, and it's that bit that we want to do now. So, this is also the case with numbers. They are all strings. So 1 is a character. It's not a number. We need to convert from strings to whole numbers using the convert character to integer. Right? It may also be a floating point. Just because I put integer here doesn't mean to say it is. You can actually convert to floating points, or what we call doubles. They're given other names as well. So but a decimal point in it basically. So here's our interface, and we've got add to list, and we've got sum, and we've got largest, and we are adding 52 to our list. So I click on the list, add it, and I put them in. Now of course I ain't gone through all of those one by one in this presentation. I've just put them all in one go. As you can see, 99 was the last one. And then I've clicked on sum. So what's the code behind sum? Well, let's have a look, shall we? And the largest. Okay, so the largest is 462, which is correct. The sum is 765. Okay, but what's the code that goes behind these? You can see this on ListBox's number 5, again, which is contained on the blackboard. So let's look at the code behind the buttons. Add button, dead simple, as before, no difference. So now we've got number ListBox dot items dot add, and then we've got a text box called add number to ListBox text box dot text, and then we've got a sum button. So here's our sum button. So we have int sum declared as 0, so we initialize it at 0 straight away. And then we use our for loop, right? We use our for loop, and we say that I, for index, is 0. If I is less than equal to number listbox dot items dot count minus 1. So what it does is it counts how many is in there, and remember, it gives us back how many items it contains, not the index. So then we have to deduct 1 to make it the index. So if there were 5 in there, it would give us an index of 4, because we're starting at 0. And then we've got a semicolon I plus plus, and that increments each time it goes round. Then we've got open squiggly brackets, and we've got the actual equation that works out the mathematics. And finally, we have the sum text box dot text equals sum to string. Okay, so let's have a quick look at the for loop. So here we go, the for. So sum equals sum. So the first instance, it equals 0. So sum will equal 0 plus, converted to 16, normally I use 32 now, the listbox number item. So it's item at the index number. So that gets us 0, the first item. And it puts whatever values in there. I can't remember the value now, but let's say it was 56. Okay? So now sum will become 0 equals 0 plus 56. So now it will be 56. It goes around again. It looks at the value of I, and it is below the count number. So it now adds the next number. And it keeps going round the loop, adding the numbers to sum, until I becomes greater than or equal to the number in the number list box items count minus 1. And then at the end, when it's done them all, it takes sum, which is declared, remember it was declared as an integer, and it actually converts it into a string and puts it into the text, in the text box, the sum text box. Largest button. Now a little bit more complicated, the largest button, but essentially we declare int largest, and the first thing we do is we go to item 0 in our list and we put that straight into largest because it's the first one, and therefore when it goes on the first instance it will be the largest. And then we enter our for loop at number 1. So I equals 1, and it checks to see if the item in the list box at I is larger than largest. So it goes to the list box and it goes to number 1 and it says this value converted into a number, is it greater than largest? And if it is, then it puts that value into largest by again doing the conversion and putting it into largest. Then it returns and gets the next one. It goes to number 2. And again, it sees is the item index within the list box converted into an integer greater than largest. And if it is, then it puts it into the largest. If it isn't, it ignores it completely. Goes back and gets the next one, and so on. So each time we're going around the loop, we increment and we look at the next item in our list and check it. But only make it the largest if it is the largest. In other words, if it's greater than the largest. Finally, when we get to the last one and count items list box number minus 1 is greater than or equal to it, then we drop out and we actually put in the largest textbox.text becomes the value of largest converted to a string. Finally, in this lecture, I want to look at contains functions. This searches for an item which is equal to. For example, if the shopping list contains the following: bread, milk, coffee, eggs, butter, and we ask it to look for tea, as here. So we're saying, does it contain tea? If it does, we're saying print yes. So if it comes back as true, it's a yes. So therefore it will print yes. However, if it's false, it will do nothing. However, what if we need to know the index of an item? So that contains gets us something, tells us whether it's there or not, but it doesn't tell us what item number it is. And if we want to do things like, for example, change, I don't know, sugar to sweet X, or sweet X to sugar, then we need to know its number so we can replace it. We might need that. So, therefore, we need to create our own search which will return as a value. So here we are, look. So what we've done here is find an item, and we've got tea, sugar, coffee, bread, tomatoes, and I've told it to find us coffee. And you can see that in list boxes number 6, again available via Blackboard. But let's have a quick look at the code. So here's my code, right? You will notice a few things. There's quite a bit here that goes in, but I've also laid it out in a very specific way. Okay? Here I've declared the variables that I require. This is good convention, by the way, doing it this way. Yeah? They're all together. I know where they are. Okay? Here are my group of declarations. So my length will be the shopping items count. Now, I could have used shopping items count instead of length. And sometimes you'll do that. Actually, probably the more sophisticated you become with your code, and the clever you understand it, and the more you understand what you're doing, you'll probably not convert them in, but use the actual element itself. So you'll not put length. What you do is you put shopping.items.count, open brackets, close brackets, in place of length. But that's not the case at the moment. Let's walk before we can run. And then we've got items wanted, or item wanted. And that, we get that from our find items textbox.text. So as soon as we click on this button, it will put that in. We set found to false because at the moment we've not found anything. In fact, we've not even started looking. And we set our index to 0. Again, because we've not started looking. Okay? And then we can set up a loop, a while loop. And we're doing a while loop because we know that we need to go into the loop once, at least, but we don't know how many times we want to go in. So therefore, it's not a while, not a do while, or a for. It could be a do while. We could change it round and make it do while. But this way, I've chosen to do it this way because I want it to terminate. Okay? While found equals false. Well, in the first instance, that's true. And index less than length. So what we're saying here is it's got to be less than the length. Well, notice we've got shopping items count. So that tells us how many items it contains. So it wants to be less than because we're going by the index number. Okay, and then we've got if shopping item at index converted to string equals item wanted, then true is found is true, and display the number of the item. Okay, so we could display the item number. Else index equals index plus 1. Now I've missed out a semicolon on index equals index plus 1. I've also missed out open brackets after while and at the end of the while statement, because it should be contained in a complete set of things. They were done on purpose to stop people from copying the material without understanding what they were doing. So make sure you read through some of the materials. Some of these things have been done on purpose. Some have been done purely by accident, but quite a few of them, in fact most of the majority of them, have been done by me on purpose to make you look and make you read them. So don't think I can't code. Okay, one thing here as well to point out is, notice I've chosen to use the while loop. That is not a good one, really. In this instance, I could have used a for loop, because I know how many times I'm going to go round. I could have also used a do while or a while loop. But really, to be perfectly honest with you, a for loop would have been better, and it would have reduced the need for an index declaration, because that would have been done on the for, and it would have also removed the need to have a length, because we know how many. Okay, and it would also remove our code, because we wouldn't need else index equals index plus 1. Yep. Also note, I said we wanted to create a method that would send back a value. So actually here, where we would normally type in private void, I would have put private int, and on found after the message box, or with in place of the message box, I would put return I. No, return index, sorry. Yep. And at the end of the code, I would have index equals -1. So index equaling -1 means we couldn't find it. It's not in the box. And we can have an if statement to pick that up. Okay. So we'll carry on going through the code as it is. So here's our while loop. Remember, I've missed out the opening bracket just after while and the very last close bracket, which goes after the one after length. Okay? And it says if shopping item at index converted to string equals wanted, item wanted. We'll say it doesn't in the first instance. So therefore it wouldn't go into the thing. Now if it did, it will go in and set true and also display. If it doesn't, it goes to index equals index plus 1. And then it returns back to our while loop and does it again. Okay? Notice on this, if it's true, found becomes true. And because found is not equal to false, then because found is not equal to false, it would also drop out the loop. By the way, found equals false, not equals. We're assigning it, not evaluating it. See? Quite a few, and that was one I've missed. This is the result. So, there we are. It says 2. I can't remember what I put in, but it was on number 2. And that's the index, not the actual item in the list. Any questions? Email me or speak with me during your tutorials. Thank you for your time, and I hope you've enjoyed this media file.